All right, well, we're going to go ahead and get started. Sam, I will unmute and unlock. He's saying that he's locked. But we'll get that figured out. So let me see here.
Yeah, I just had to turn on my mic and camera and I was good to go. So maybe you can double check and make sure he's doing that on his end.
Okay. All right. Why don't you go ahead and get us started?
Yeah. So, sorry for showing up late. We were having some issues. But my name is Sam Myers. If you've never you've seen me before at any of the conferences or trade shows that Nikki and I attend quite a bit, I serve as the in-house building science consultant for RetroTech. And at RetroTech, we manufacture diagnostic tools for measuring air tightness in building enclosures, measuring airflow for all kinds of scenarios. And we specialize in building high precision manometers. So really all things building science, taking measurements, ensuring things are going to be built the way that they're designed, and hunting down problems in existing buildings. Before my life here, I was a building science consultant at a company called Advanced Energy out of Raleigh, North Carolina. And the special thing about Advanced Energy is they did much of the first research in encapsulated crawl spaces to really see if that approach to those spaces will actually work. And a lot of that research is what led to encapsulated crawl spaces being allowed into code for many different states. So really, they're the reason why we are able to do this. And we still use a lot of that first research to really prove the point of why encapsulating crawl spaces is the way to go in pretty much every climate zone. That was one of the cool things that they did. They did a lot of stuff in Eastern North Carolina, which was a really good starting point because here where I live on the coast in Wilmington, North Carolina, we experience all of it. We get all 4 seasons and we have high humidity. So we have to build an assembly that's going to work for all of that. And encapsulated crawl spaces seem to be a much better route to go than vented crawl spaces from what we've seen. So the research that happened at Advanced Energy was before my time there. I think that really kicked off in 2001. I was in 8th grade then, so a little bit before my time when I hit my career going. But a lot of that has been driven into me pretty hard. When I was at Advanced Energy, we taught contractors how to do an encapsulated crawl space properly. We also served as consultants for our utility providers when homeowners would call in to try to see which route to go, and we would serve as guides for them as well. So we'll kind of kick into what some of this early research showed us and where we have gone from there. So was that the next slide after the intro slide, Nikki?
Yeah, the need for encapsulation.
Cool. Yeah. So this chart came from some of that early research. You see crawlspaces.org. We'll get into that later, but that's actually Advanced Energy's website where a lot of this research is stored, and it's still up and active. But we can see some data here that's been tracked. With the blue being your traditional wall vented crawl space, green being the outside conditions, and red being an encapsulated crawl space. And this is looking at relative humidity on the y-axis, and then on the x-axis, we're just looking at time across the summer. And we can see that the vented crawl space, as you would expect, it's open to the outdoors. It kind of tracks a similar line as the outside. Where in a lot of cases you'll see, some areas will get below dew point, which will cause moisture to condense on surfaces. But if we actually take control of that, encapsulate it, and keep some kind of drying mechanism, a dehumidifier, to really control that space, we can see that everything kind of stays constant throughout the summer so that we don't have these conditions where mold will grow and we'll get wood rot and things like that. So it's not that the crawl space needs to stay like the rest of the house. We're not trying to keep it comfortable. We're just trying to keep it dry. That's the goal. So you can see this GIF here. It looks like it's straight out of 1995, but I love it because it's still the same graph or the same diagram that's on crawlspaces.org that kind of came from that early research to really prove the point. It's simple. It's simple to understand. If we have a basic understanding of how relative humidity works, we can see that this 90-degree outdoor air at 50% relative humidity, which where I live is very common throughout the summer. Once that air comes in through the vent and meets that cooler vented crawl space, now we're at 75 degrees and that air is fully saturated. So that moisture's got to go somewhere. So that's when we see things condense on wood surfaces where mold will grow. In some really bad cases, we've even seen it condense on fiberglass insulation itself. And in my experience, this can happen in a crawl space without any ductwork in it. But once you put leaky ductwork in a vented crawl space, it just amplifies it. So those two just really do not go together. And then we can see how the wood moisture content also is directly related to the moisture content in the air. So if we go next, I think a couple of times to highlight some of these, these columns here. If it decides to work, here we go.
Oh, sorry.
Back one. There we go.
There we go.
So if we see our temperatures going from 70 to 90 degrees, and we start getting up to our moisture content in the air at 90 to 95%, which happens quite a bit, especially where I live. It usually happens early in the morning in the summer. So when we start, it's not quite warming up yet, but the air is still pretty loaded with humidity. Now we get into where the wood can become saturated to dangerous levels. So this is why wood rot occurs. So it's directly related to the conditions in the air in that crawl space, because once we have that warmer saturated air come into that cooler crawl space, the same thing kind of happens when you take a glass of ice water and set it outside on a warm summer day, it condenses. So that's exactly what's happening inside the crawl space. So, before encapsulated crawl spaces really became the way to go, there were some other things that were tried. This is a house where on the left side, you can see that there's a little bit of mold growth on the joist. And so what the contractor decided to do was, okay, well, it's not vented enough. So let's put an exhaust fan on it and just bring in outdoor air even faster, which made the problem worse. So this is that same joist, and you can just stab a dull Swiss Army knife through it. So what those vents are, designed to do, the whole idea is that, having vents to the outside is going to regulate that space, when really all it does is just invite problems to occur. And then if you drive that air in faster with an exhaust fan, these are the kind of results you should expect to see. So that's not going to work. We want to keep that outdoor air out. But, moisture can get into any assembly, any of four ways. And a good way to remember that is A, B, C, D. A for air, B for bulk water, C for capillary action, and D for diffusion through materials. And so sometimes bulk water can work against us as well if we don't have good drainage. So we always want to make sure if we're doing a new build or if we're doing a rehab on a house, is just drain the rain down the plane. Make sure you have drainage away from the house. So if you have gutters, don't let it just dump right there at the side of the house. Make sure you have a way to guide it away so it's not going to puddle beside that foundation wall and trickle upward into that space. So these are some good examples of that here, where we're actually pushing that rainwater away, so it's not just going to hang out there and find its way back inside. So if you go to crawlspaces.org, this is Advanced Energy's website. You can actually download the guide that they put together a long time ago. And everything in there is still pretty much the same, but there's a couple of things that I would recommend maybe staying away from that we've learned in recent years. So this first example here, this is probably my second favorite way to condition a crawl space. from what we've really learned, you got to have a dehumidifier to do this right. I mean, if you're in a humid climate where the source of the humidity coming in is from the outside, that is going to be the best way to treat it. And as Nikki can tell you, that technology has come a long way. They're really not energy hogs like they used to be. But I won't spoil some of Nikki's talk. She's going to go into that pretty heavily. But in this scenario, what you see here, you see the insulation on the floor, which is fine. I mean, it works, but one thing about that is a lot of the times that's going to be like fiberglass bat insulation that's going to be pinned up with something like tiger teeth, and so it actually compresses it, so you lose some of that R value in the floor. Also, you're working against gravity when you have that in the floor, so eventually it's going to fall down, or if somehow something gets in there, it can pull it down. So like I said, this is my second favorite: the dehumidifier, the encapsulated crawl space, the drain to daylight or sump pump. All of those are key. We can see that we have a vapor barrier across the bottom of the floor that works its way up the wall. And then we can see towards the top of that wall, about 3 inches from the top of that foundation wall, we leave a gap for termite inspections. In most of your states, that's going to be required, about 3 inches. So that part is going to be open and exposed. But a trick that John Tooley showed me one time is that if you actually paint that with white mastic, it actually helps seal that concrete. And if you go and inspect for termites later, they're easier to see with an LED flashlight. So that's a nice thing to remember. But let's go to the next one. This is my favorite way to do it. Instead of insulating across the floor, you can actually just insulate the foundation wall itself, whether if it's with spray foam or with rigid foam insulation. It's just cleaner. You don't have a lot of the particles floating around in the air that will get collected in that fiberglass insulation. It is mechanically fastened to the wall. So you're not fighting gravity with something that's just kind of pinned up to the floor. So the chances of it staying there for a very long period of time are very, very high. Everything else here is the same. The only thing that we're changing is where we're putting that thermal boundary. So we're still going to have to insulate the band somehow. So you'll still see maybe some fiberglass bats there. If that's the route you're going to go, just make sure you air seal that band joist. That's a pretty big leaky point that we see in encapsulated crawl spaces, or you can just spray foam it. We see a lot of that too. So there's some different ways to treat that. But when you insulate that space, you just want to make sure it's going to get air sealed also. The next slide is the same as the first one, except for with the dehumidifier, what we see here is ductwork in the crawl space with a small supply that's treating it. This is how we did a lot of our houses at Advanced Energy. And then when we went back and started data logging it, there's a couple of things that we realized. The first was that I'm trying to remember what the goal was. I think it was like 1 CFM per 100 square feet or something like that is what we required. And in a lot of the cases on the really humid days, it just wasn't cutting it. We were getting relative humidity in the crawl space, and we were logging it over that 60% that we didn't want to cross. So we just didn't have the control down there that we thought we had. Also, we are putting air in a space from the HVAC system that isn't making its way back to the return. So we're actually making the house imbalanced. So if we are losing supply air that way to the crawl space that we're not going to get back to the return, that can put a negative pressure on the house, especially if it has a tight envelope, which, if we're going this far to treat the crawl space, likely we're going to treat the building envelope too, if this is a new build or a gut rehab. So we're actually driving infiltration in the rest of the house more through that mechanically driven infiltration. So not only does it not do that great of a job at keeping the crawl space as dry as we want, it can also introduce other problems in the rest of the building shells. So we did this for a while. It was kind of hit or miss, but in a lot of cases, even in less humid parts of the state, as we moved west, we were still seeing issues where it just wasn't keeping up like we thought it would. This is the exact same scenario, just with that insulation moved down again. So those are, as far as like drying a crawl space, those are really the two mechanisms that you'll see, and just what we've learned over the years. they're not equal. The dehumidifier just seems to do a much better job of keeping it under control throughout the day, throughout the year. A challenge that we run into, again, Eastern North Carolina is a really good guinea pig for this kind of thing because we also get hurricanes and lots of flooding. And so, okay, well, what if I have a crawl space and I have to have flood vents by code? Well, there's some options out there. You can get airtight flood vents that will work for an encapsulated crawl space. God forbid that does happen. There are materials out there that are available that you can use to still have an encapsulated crawl space and meet code if you're in a flood zone. Radon's another one too. This is easier at the beginning. So if you're doing a new build, it's a lot easier just to go ahead and put this in rather than after the fact. Because if you go in and put a radon system in an existing home, a lot of times it'll be visible from the side of the house. Unless you get really creative and find some pathways through the house where you can get up through without maybe finding a space in a wall assembly or something like that. But that's another one of the challenges of an encapsulated crawl space is, well, they trap radon, and if we don't have a way to get rid of that, it can make its way into the house up through the floor assembly. So what this does is it's a pipe assembly that has a T that goes underneath the vapor barrier of the crawl space, collects that radon, and gives it a pathway to move upward and exhaust out of the house without making its way inside. So that's essentially how it works. Sometimes they can be passive, sometimes they can be active with a radon mitigation fan. It's always good to test these with a high resolution manometer to make sure that they're going to actually work and do what they're designed to do. But yeah, you can do this. You can mitigate radon and have an encapsulated crawl space. You can have a similar assembly for slabs also. So for more information, feel free to look more into that. But that's just kind of the quick and dirty of where the idea of encapsulated crawl spaces came from, where some of the research was done, and what we've learned along the way.
All right, Dane, you're up next.
All right. Hey, everybody. Can you guys hear me okay?
You're a little quiet, Dane.
Little quiet, Dane.
All right. Is that any better?
A little bit there at the end.
Okay. I'm trying to
I think as you move closer, it gets better.
Okay. Well, you're gonna get a upfront look at my face, and I'll try to speak loud as possible. So appreciate it. Sorry again for the little trouble getting in. But happy here, as Nikki and Sam probably mentioned. My focus is centered around the vapor barrier side of things, moisture control from diffusion and capillary action that we have going on in the crawl space. And so one of the biggest components of crawl space encapsulations is using a vapor barrier, and what makes a quality vapor barrier. And so there's a lot of misconception out there. And so one of the biggest things that we try to tell people is that mill thickness is not what drives a quality vapor barrier, but there are some very specific things that do impact that, but thickness of the product is not. So when you hear things of people using a 6 mil, 10 mil, 12 mil, 20 mil, we even see claims of 125 mil. That doesn't really matter. What matters is how the product is made and what it's made with. And so when we look at things like that, the first place we start is the raw materials that it's made with. And so in looking at quality vapor barriers, you have a choice of recycled resin or virgin resin. And while recycled sounds great, the more times we recycle and regrind polyethylene resin, we drastically shorten that lifespan. If you've ever noticed going into a crawl space or attic spaces, you start to see that standard recycle regrind polyethylene sheeting becomes very brittle. It can oftentimes just break under the pressure of your hand or crawling on it. So you drastically shorten that lifespan. It also only gives you a fraction of the performance. When you select certain resins, you select them for characteristics like durability, longevity, performance in certain aspects. The more times we break that down in the regrind and recycle process, you start to lose some of those inherent properties. So maybe you only get 80 to 90% of that performance that you would if that was in its virgin state. So one of the big things that we try to recommend people is to look at a virgin resin polyethylene sheeting. A great signifier of virgin resin versus recycled regrind resin in your polyethylene vapor barriers is going to be the color of it. If you're using a clear product, you should be able to see directly through that material. It shouldn't have that milky yellowish color that you often see with standard polyethylene sheeting, and that's a huge signifier of high recycle regrind content. Nikki, if you go to that next slide, or maybe one more, you can see here's this is oftentimes what we see in traditional crawl spaces, whether it be vented or closed crawl spaces, is that 6 mil poly is still code allowed. And so this is oftentimes what you run into. And I think, Nikki, if you show it, it just shows how easy that product can tear and break down. And so this is oftentimes what we see a lot of contractors having to go in there and replace. We know that regrind recycle resin is just not a true solution for an encapsulation. When we think about the end goal of this crawl space, if we're going to have other trades that have to get down in there and inspect for pest control purposes, or we have HVAC equipment that's down there that we need servicing, we need something that's going to have that durability and longevity. And so when you start to use virgin resins, you can see some indefinite lifespans, so much so that that products are out there now with warranties and lifetime warranties on them, free of breaking down. So that's the first thing that we want to look at is the resin, is what it's made with. The second thing, if we move forward, is going to be whether that's a single layer or multi-layer film. And so what that means is the way polyethylene sheeting is made is all of that resin, that raw material, those pellets of polyethylene are filled into hoppers and then drained down into an extruder where it's melted down and blown into a large bubble. And so what you have the option of doing is you can have a single hopper with a single extruder, and oftentimes that's how traditional polyethylene sheeting is made. Single hopper, recycled resin, blown down to a specific thickness. The problem with that is you don't have the ability to select different resins for different characteristics. Some are much more durable, some have a much longer lifespan, or maybe have different performance characteristics that we want to combine into a finished product. And so when we look at a multi-layer or co-extrusion process where we have multiple resins selected, we have multiple extruders, anywhere from 5, 7 to 9 different extruders that are melting down different resins and blowing them together to make that finished product, we can start to stack performance on top of each other and get a much more higher performing product to specification at the end, rather than just blowing to a mil thickness. And when you have a single layer film that utilizes recycled regrind resin, you oftentimes have a huge variation in what that end product is going to be, whether it's post-consumer recycled material or whether that's factory scrap waste. It can have a huge variation. And unfortunately, we still see a lot of people just focused on the thickness of it rather than the performance characteristics of that. So I think if we move ahead, that's just kind of what we were talking about there, monolayer film versus multi-layer film. And I think, Nikki, one more slide has a picture of what that manufacturing process looks like. So you can see here, when we're looking at a 5-layer machine, all of the different hoppers that are containing those resins, we can select for different characteristics, and it goes through the extrusion process, so we can really start to have a much better product. All right. And one of the unique things that we found as we started to hone in on, what makes, a high performance vapor barrier is in the underslab world, where we spent, the last 25 years and commercial projects really driving the industry for it, is that in the crawl space world, we're being left exposed. So we're going to see more foot traffic or construction traffic than in an underslab application, where once we put concrete over it, it's protected. So the need for additional reinforcement was really driven out of, you know, the contractors and the homeowners who wanted to turn these crawl spaces into a more usable space or something that's going to have that durability. And so the age of reinforcement came as encapsulation has grown. And you really have two options when we're looking at additional reinforcement for polyethylene sheeting. You can have what I think most people are familiar with is that bottom option, which is a nylon or polyester string reinforced product. And that's essentially where we're taking multiple layers of polyethylene sheeting and laminating them over that cord reinforcement. So it does add additional tensile strength or tear resistance to the product. What it doesn't add in way of that is any puncture resistance or additional permeance protection. And so when we started evaluating what's the best for actual crawl space encapsulation, not just using products that exist, woven reinforcement proves to be a much better solution, and that's that top. So if we move forward, Nikki, what's nice about a woven reinforced product is it actually takes individual strands of polyethylene sheeting and it's woven together in an 8x8 or 12x12 per square inch pattern throughout the entire product. So it's not just a lamination over a cord reinforcement, it's actually a built-in ripstop throughout the entire product. So it really gives you tremendous tensile strength, but also added puncture resistance because all of those individual strands are working together for that durability. And then what's nice about it, as you extrusion coat it, once it's woven together, all of that polyethylene fills into all those nooks and crannies, and you're essentially extruding a film on top of that scrim. It provides tremendous permeance. So in permeance, we're looking for a lower number, the better, how much moisture is actually able to travel through that product. So that's where there's a huge benefit to a woven versus a traditional string reinforced. And one thing that, you know, we've kind of noticed that wasn't, you know, a performance standard that we're going to look at was with your string reinforced products, because you have a nylon or polyester cord reinforcement in that product. When you cut that, you're exposing the edges of that cord reinforcement. And with those materials having the ability to wick moisture and actually draw moisture in through that, we can oftentimes trap moisture between those layers of polyethylene. And what we found is they can emit some pretty foul odors. So if you've ever heard of, you know, ammonia smell or cat urine smells in crawl space encapsulation, what we found, and, you know, there's been a lot of money spent from industrial hygienists and companies trying to replicate that, is that when you have material that traps moisture in there, you can start to get those foul odors. And so not something that you'll find on a data sheet, but just something to think about. What we want to use down in the crawl space, as it's a part of our conditioned space now, is something that, you know, is completely inorganic, isn't going to draw moisture in. It's just 100% virgin resin polyethylene with as little additives or anything else that we can throw in it. We just need it to do its job as much as possible. And that's where what really matters with vapor barriers and what truly makes a quality vapor barrier are the performance standards. And so if we slide through, I think one more slide, Nikki, is so with standard polyethylene sheeting, which is your standard code 6 mil poly, this is oftentimes the performance of that product. If you were to request data sheets, this is essentially what you're going to look at. And so what this shows is the puncture resistance, the tensile strength, the permeance required for those products, and typically what they're at. So you can kind of see, based on the mill thickness, what level of performance it has. And so if we look at, 6 mil poly on table 1, which is puncture resistance, it has about 260 grams of puncture resistance. When you look at a woven virgin resin reinforced product, a product like that in the exact same test will have over 8,825 grams of puncture resistance. So when we really say that mill thickness does not matter, that's based off of the performance standards. We want to really look at what you're asking for. You're asking for that puncture resistance, that durability, the permeance, and the same goes for the other qualities as well. So when we look at permeance, 6 mil poly has a 0.13 perm rating. When the industry kind of looks at what is a vapor retarder versus a vapor barrier, it's that 0.1 perm rating that is the benchmark for a vapor barrier, if you will. And so while this table kind of is what's used for 6 mil poly, standard 6 mil poly, it's kind of inferior to what the industry is really moving towards or trying to drive to. And that's the next slide, which is ASTM E1745. So this is, what's nice about this is it's irregardless of mill thickness, it's all about performance. And so what the industry has really done is classified these products as A, B, or C based on that performance. And that benchmark, even to be a Class C vapor barrier, is going to be that 0.1 perm rating. So that is the main number one goal that we're trying to achieve, is a very low perm rating on this product. And then we start to see, as your durability increases, that's how you move up that chain to a Class B or Class A. So if we look at the puncture resistance requirements for a true Class A vapor barrier, it's going to have 2,200 grams of puncture resistance. If we go back and look, at what 6 mil poly is going to have 260 grams. So far short. And 10 mil standard poly is going to be around that 475 gram mark. So again, not a Class A or Class B, barely meeting that Class C. So that's really where we've seen the industry shift towards, is a performance-based standard for vapor barriers. We've seen this is what's required on the commercial side for underslab buildings. This is also what the radon industry, the ARST community, utilizes in their standard for vapor barriers to protect against radon and used in the radon mitigation systems. Is this standard is a much better judge of what makes a quality vapor barrier. So and this is just a nice side-by-side comparison that that we put together to kind of show that, is a lot of times the perception is, well, if I'm using a 12 mil and my competitor is using a 10, the assumption is that 12 is better if it's apples to apples, but oftentimes we know that it's not. And so this is a really good side-by-side comparison to show, via the exact same test methods, how a 10 mil woven can outperform a 12 mil string, a thicker product, whether it be in puncture resistance, tear resistance, the perm rating, in every category that's important in crawl space encapsulation. That woven reinforced really offers the most benefit there. So that's really what we try to promote and look for in a quality vapor barrier for crawl space encapsulation. And
All right.
I think that's it.
Thank you, Dane and Sam. My name is Nikki Kruger, and I'm the Director of Marketing and Business Development for Santa Fe Dehumidifiers. Just a little bit of background. Thermistor is the company located in Madison, Wisconsin, where our manufacturing facility is. We invented whole house ventilating dehumidifiers back in the 90s, and we're first to market for the horizontal dehumidifiers used in crawl spaces. We also manufacture industrial dehumidifiers and restoration equipment as well. If you've heard of Paul Davis or ServPro, we actually manufacture their dehumidifiers. So our sole focus is dehumidification. One of the articles that I kind of like to note here is, when it comes to vented crawl spaces, Dr. Joe Steenbrook, who is the godfather of building science, you can find all of his articles for free and presentations at buildingsciencecorp.com. But, when we look at things that we're not doing correctly when we're building our homes, one of them is having vented crawl spaces. And that, again, it can make our homes sick, or make us sick in our homes, and also cause a lot of property protection issues and comfort issues in the home. So when we look at building building codes. The 2021 version offers all of these ways that we can condition our crawl spaces once we close them and making them unvented. And Sam already kind of touched on these. The most common is using that 2.2 up on the right there, that supplied air delivered. And so we're basically allowing some air from our air conditioning to be put into the crawl space. The challenge with this is typically when it is the highest dew points and the wettest out is our spring and fall times. And that's not when we're running a lot of air conditioning. So trying to use some cool, dry air to actually regulate the relative humidity in our crawl space based on our comfort on a thermostat in the living space can be very challenging to keep it always below that 60% relative humidity. Once we go above 60%, that's when we can start getting microbial growth if it lasts longer than 72 hours, which is very common. The other thing with this is if you look there on the fourth line down, you have to have a transfer grill or a pathway of return air back to the living space so we don't create a negative pressure in the home or a positive pressure in the crawl space, which I've been in enough crawl spaces to know I don't care how well they're encapsulated. I do not want to be sharing air from my crawl space with the rest of the living space, especially if you're in climate zones where we are doing a lot of, termite treatments and pest control treatments. I don't want any communication with my crawl space in the living space. But as you can see in here, number 2.4, dehumidification sized in accordance with manufacturer specifications. Now, if we look at up there, you can see this is the 2018 IRC code. I worked with Joe Steenbrook on getting dehumidifiers into the International Residential Building Code, because before the 2018 version, dehumidifiers were not an option unless you lived in North Carolina. And that was because of advanced energy. That was the only state you were allowed to use dehumidification to control and condition the space, when all we really care about is the moisture at that point. If we've done a good job of air sealing and getting using a good vapor barrier and really getting that crawl space closed up, when it comes to temperature wise, there shouldn't be that much different from the rest of the house. But really what it is the moisture. Now here we said 70 pints per 1,000 square feet. We got it wrong. Because you can have a 3-foot crawl space that's 2,000 square foot. And if you've done a really good job of sealing that up, a 70-pint dehumidifier is probably all you need. So if you went to, 1,200 square feet, then you're going to need 2 70 pints. And so we worked on it. We got it correct. Now, I do have a lot of people calling me say, wait a minute. We're on 2018 code or we're on 2015 code, so I can't use a dehumidifier or I need to use more than 1 per 1,000 square feet, and that is not correct. You can always go to the 2021 code or the next version of code, and they can't penalize you for doing better. You can't go backwards, but if you have an inspector and you say, okay, well, here's the 2021 code. It says per manufacturer's recommendations, they have to accept that. They cannot enforce that it's the 70 pints per 1,000 square feet. So something to note, because I do get emails on that quite often. Now, again, we talked about using that supply air. And again, contractors like that a lot because there is no, and homeowners, because there's not additional equipment needed. Basically, you can just pull some of that conditioned air, but it's cold air going into a cold space. It's only based on when the homeowners are running their air conditioning. You're not getting it to a specific set RH, and it can cause comfort issues in the house because if the air conditioning system was never sized for that crawl space, Now you're taking conditioned air that was supposed to go into that living space and putting it into another space. So while it is inexpensive, it really is not effective. And this is a picture, and it looks really nice, but again, not real effective at controlling relative humidity. There's a lot going on here, but this is 2 crawl spaces, habitat ones that were built right next to each other in Northern Virginia. The solid lines are the outdoor conditions, and the dotted lines are the indoor conditions. And so on the right side, we've got AC supply, the left side with a dehumidifier. If we look at that orange dotted line on both sides there, you can see we had the dehumidifier set a little low in the closed crawl space with the dehumidifier for a little while until we went in and adjusted it. But the data here shows that, once we use a dehumidifier, we can just set it and forget it. And about 55% is where you want to set it at the dehumidifier. And that helps ensure that the farther areas of that dehumidifier or of that crawl space won't go above 60. But again, that supply air, it's just going to fluctuate based on how the homeowners operate their HVAC system. So, no control, it's inexpensive, and allows, communication through the spaces when we use any of those other conditioned options by code other than using a dehumidifier. So, there's a lot of things in our crawl spaces, especially when it comes to using pesticides, that can be hazardous to our health. And there are studies out there that, have shown this. Some of these contaminants that are in the crawl spaces here, besides things that are just kind of growing, but when we start using those pesticides, there's a lot of other things that can contribute potentially to poor indoor air quality in the living space. So here we are, dehumidifier size in accordance with manufacturer's specifications, which is much better to have this in code than it was a 70 pint per 1,000 square feet. But now we really have to get into, well, what's the manufacturer's specifications? And there are some things that you need to understand about the manufacturer's specification, because there is no governing body that basically dictates how we're all sizing or the data that we're releasing about our dehumidifiers. So a dehumidifier will always keep it the relative humidity hopefully below that 60%, which means that we won't get microbial growth. Odors from the bacteria will be minimized. Actually, when we control the relative humidity below the house, you can actually make it much more comfortable in the living space, because high humidity goes to low humidity. So if they're running their AC upstairs and the humidity is lower upstairs than it is downstairs, that moisture is going to try to make its way upstairs. So they say about up to 50% of the air that's in our living space comes from below the home. So being able to control that. And then plus, if there's hardwood floors, we really want to make sure that we're controlling that relative humidity, because the warranty will not cover most of the time those hardwood floors if you're not controlling the relative humidity. So it really is the only viable solution to removing moisture and not just trying to dilute it with some of those other conditioning strategies. So sizing dehumidifiers is a question that we get all the time. And, it can be based on a lot of things. How well was it closed up? The size of the space. Temperature affects also what that relative humidity is. That's why dew point is something really important to understand versus just the relative humidity, because relative humidity is always based on the temperature. And so you can have a high temperature with what looks like a lower relative humidity, but the dew point still might be high. So what we have here is two 70 pint dehumidifiers. The one on our left is our whole house ducted dehumidifier, and the one on the right is our standalone Compact 70, which is usually used in crawl spaces and basements. And the DOE, we used to rate all our dehumidifiers capacity at 80 degrees and 60% relative humidity. In 2019, the Department of Energy said that's not realistic. Our homes aren't 80 degrees, our crawl spaces aren't 80 degrees. So, and then they said, well, the living spaces in our houses are actually different even than what's going on below our houses. So they make us rate our dehumidifiers for whole house now at 73 degrees and 60% relative humidity. And our standalone portable dehumidifiers at 65 degrees and 60% relative humidity, because those are more realistic into the applications they're going in. So our whole house dehumidifier, 70 pint one, at 73 degrees and 60% relative humidity is 55 pints. Now, if you take that, basically the same dehumidifier, and put it into a portable application, which is 65 degrees and 60% relative humidity, that dehumidifier goes down to 40 pints, because the temperature going into the dehumidifier is what is going to affect its capacity. And so we really want you to understand this. So if you are encapsulating crawl spaces or closing up, you understand what the true performance is of that dehumidifier that you're putting into those spaces. So one way to kind of think about, well, how much dehumidification do I need? Ultra Air used to be our whole house ventilating dehumidifier brand, and we combined it with our Santa Fe one. That's why. But we have an app. You can find these apps. It's they're outdated, so sometimes they're tricky to find in the App Store. But you can look for Ultra Air Psychrometric Calculator, Santa Fe Psychrometric Calculator. And if you can't find it there, it's the same thing, just different branding under the Phoenix Psychrometric Calculator. And if the inlet are what the temperature and conditions are outside. So I'm saying it's 84 degrees outside, 68% relative humidity, and that's going to automatically give me my dew point. The outlet is what I want it to be inside. So I've got 68 degrees in my crawl space. I want the RH at 55, and I want a 51 degree dew point, meaning hopefully my water pipes and my ducts, I'll get no condensation, hopefully, if I have that 51 degree dew point in my crawl space. And I'm going to say the flow is kind of the infiltration. What's coming in from the outdoors? Even if we air seal it really well, we're probably going to have some infiltration. And this is saying that based on these conditions, what's outside, what I want inside, and the approximate infiltration, I'm going to need at least 50 pints of dehumidification a day. So it just gives us an idea when we know some of these things on what size dehumidifier, based on their performance data, of what I'm going to need in that space. So, you know, humidity removal is very important. Using a dehumidifier that is high efficiency, so we're not, you know, we're using as little humidity as possible. Ones that have low temperature operation are really important. Typically, when you buy one from a big box store, they go into a lower temperature. They start freezing those coils right away. They're not made to be used in cooler spaces. And then, you know, air filtration. All of our dehumidifiers do have MERV 13 filtration, which helps protect that dehumidifier, the coils, but also, like we said, up to 50% of that air is going into the living space. So we're also going to be minimizing the amount of contaminants that are going into that living space. So we give you all kinds of different size dehumidifiers based on what your specific application might need. You might need more than 70 pints down there, especially when you look at that performance data. So if you can, we always recommend, and I think I've got a picture here, of adding some supply flex duct to that dehumidifier in order to get that dry air away from the front of the dehumidifier where the sensor is located, because we don't want to create a microclimate right around that dehumidifier. Plus, this allows us maybe to, if the plug and drain is located more next to the crawl space door, and we can get that drier air to other corners of the crawl space. And, you know, the filters need to be changed on these. We need to make sure that we're checking those condensate drains. So if we can put the dehumidifier a little bit closer where it's accessible and use that duct to get that drier air moving around that crawl space, we're going to get far more better control of the relative humidity throughout the entire space. So again, we talked about those big box units. You know, I think the best quote I ever heard from a consumer was, you know, a Santa Fe kind of isn't your first dehumidifier, but it's your last. As they had to go through several of these portables before they finally decided that, you know, it's time just to invest in one that was actually designed for a crawl space. And again, usually you get about a 1-year warranty on these. We have always had a 6-year. Well, at least for the last several years, but we recently just changed it from a 6-year being 2-year replacement and 4-year parts. We now offer a full 5-year replacement on our dehumidifiers plus a 1-year parts. So it's really the best warranty that's in the industry. For those of you that are interested in learning more in depth about maybe how the building science of encapsulating crawl spaces and how to, we actually teamed up with Advanced Energy about 7 years ago, and with leading building science experts, Joe Steenbrook, Allison Bales, and a handful of others to compile a 2-day crawl space building science encapsulation class. So it goes into the building science because you really can make a home worse by not doing it correctly. That is the foundation of that home. But then you also go into a crawl space at REITs Drying Academy and do hands-on crawl space encapsulation. It's a 2-day course. I've got a link here. You can put in REITs Drying Academy. The next class is in October. They're taking registration now. And it really, we've had people that have been in the industry 20 years encapsulating crawl spaces come to that class and, you know, kind of question some of the choices of how they've closed crawl spaces in the past. So we talk about code versus best practices. So it really is a very educational class, and I highly recommend it. Dane is part of that class as well with the liners. So we really go into all aspects of that. So at this point here, I know that we are kind of gone over our time a little bit. We will be sending out this recording to everybody. I do apologize for the technical difficulties. We have all of our contact information here, and happy to, if you reach out to us, we will definitely be happy to answer any questions that you do have. I'm just going to try to get back to my window here to see if we had. Can you guys see if there's any questions at all?
Yeah, Brenda asked if a dehumidifier would work in a mobile home.
It absolutely can work. I mean, even in a mobile home, we have different options. We actually have an in-wall dehumidifier that is applied. You can find that on our website. It's called the MD33 in-wall dehumidifier, which is a great solution for in the mobile home. If we can't get that, you know, kind of tightened up underneath, which I know it can be very challenging with mobile homes.
And that's the only question I'm seeing in the chat box.
All right. Well, thank you everybody for joining us today. As I said, we will get this recording sent out to you, and all three of us, or if you reach out to us, are happy to answer any questions that you do have.
Great. Well, thanks,
last-
Nikki, for putting this together.
Absolutely. Thanks you guys for joining us.
Thanks, everybody.
Thanks.
Have a great day.